Looks like I'm live. Hi. Cool. Okay. Looks a little different. Like I said, after the stream yesterday, I spent pretty much the entire, I had a really good session with a student. And then I spent the entire rest of the day and kind of stayed up late working on rearranging my space. And it's completely rearranged and reset up, and I sort of deep cleaned the whole room. As I did that, dusted everything, cleaned everything off, just completely reset the room. It feels nice. I'm tired today, as a result, and I don't really feel like I have a ton of energy to be like on right now. And I have another student that I'm just really anxious about after this. It's a middle school student. It's not an age, it's a 7th grader, and I don't work with students that young terribly often, and honestly, they kind of intimidate me. And it's for somebody in my neighborhood, and so it's going to be in person, and I don't do in person anymore, and it makes me really anxious to be in people's houses, to just leave my house at all. So I've just been anxious about that all day, and that's sapped a lot of energy. Not to mention chores, and it's just been a lot. I have to get used to the new setup. Things are on different sides. I've sort of mirrored my desk. It sort of made sense with the new layout. But that means I have to get used to that. Hi there, though. I'm Ryan, the calculus tutor. This is after school homework help. You can submit your well, here we go. There is a question submission, not an actual one, but a student of mine who I work with one-on-one sent me a question that we can work on here. They sent me their work, so give me a second to look through their work. Actually, it'll be easier to look at it on the computer. I don't even know why I checked this email on my phone. It's not where I like to interact with email. If you'd like to submit a question for me to answer, you can go to thecalculustutor.com. Let's walk through that really quick, and then I'll address that. The student that messaged me. We'll address their question. Okay, so sorry about that. If you would like to submit a question, you can go to thecalculustutor.com. So you go to your browser, and actually, maybe you do this on your phone. You'll see in a minute why. It might be easier to submit questions via your phone. But you go to thecalculustutor.com. Pretty straightforward. I know calculus is a little tricky. Let me share this. So if you go to thecalculustutor.com, this is what you'll see. Actually, here, let me Let me log out so it looks exactly like what you will see. There you go. This is what you will see. And in fact, this can be your one-stop shop for math, at least math help with Calculus Tutor. The stream is here. You can see the stream. You'll have to click through into actual YouTube to get into the chat, the live chat. But yeah, go to thecalculustutor.com, click the down here in the stream box, the pink stream box, click submit a question. It'll take you to this page. We'll let it load for a second. It's going to bounce around, fully load, and then scroll down to the submit homework problems. And you can, there's a button here that'll take you to the homework submission form, which is the probably preferred way for you to do it. But you can also just email me your questions directly, ryan@thecalculustutor.com. But let's say you're going to try to use the form. You're going to go ahead and do that. And this is what it should show you, though. Before it shows you this, it may ask you to sign into your Google account. You can submit images. And if you submit files via Google form, Google requires that users include their are logged in with their Google account. So that's why that is. And so if you log in with, say, your school Google account and then it tells you can't access it, so maybe you go back to the website, you click the button again, and now you're signed in, and it still won't let you access it. That's probably because your school. Give me 1 second. That would be because your school has your Google accounts locked down in such a way that you can't access materials from outside your organization. That's not super uncommon. So if you can't access this form, please just submit your question via email, ryan@thecalculustutor.com. What I'm going to go through here will tell you, what to include. And there's also guidelines back on the site for what to include, so I can best answer your question. So let's go through this really quick. If you can't access it and you email me your question instead, please tell me that you couldn't access the form. And if you think of it, include your school district, and I will try my best to reach out to them and see if I can make my form accessible to you and other students in your school district. Yeah, so go through here. You'll have to check this box to say, yes, this is my email address, and you can include it. And then first off, just put your name on it. Tell me who you are. This doesn't have to be a real name, just however you'd like me to refer to you. So like when I'm on here, I'll be like, oh, this question was submitted by such and such. You can include your pronouns here as well. Right, really simple. There's no particular format. Just a name for me to use. Whatever name you'll recognize, so you can. This is for you to know when I'm answering your question, right? All right. Then where did the question come from? This is also really simple. Just two things, right? So you might say, mix Jameson geostats. Boom. Look, you need no punctuation or anything. You can put a comma if you want it. It doesn't matter. Just teacher and class. This is going to help me organize your answers and help other students who might be in your class find this answer, because chances are if you have a question about something, other students do as well. So that's just for organization purposes. And now finally, the important part is here's where you ask your question. The key here is to be as specific as possible. So what I don't want is for you just to come down here and say, number 12. And then down here you include a picture that's just a picture of just your entire textbook page or the entire worksheet, right? Go ahead and send your entire textbook page or the entire worksheet. That's totally fine. And tell me what number you want me to focus on. Again, totally fine. But we want to be a little bit more specific than that. Now, that could be, you just saying number 12, I got parts A and B, but part C requires graphing, and I don't know how. right? That's good. That's pretty specific. This is actually quite specific. It tells me I don't really need to spend much if any time on parts A and B. I probably still will, but I'll probably sort of breeze through them initially so I can get to part C. I'll go through parts A and B, especially if you sort of need to do them to work on part C. But regardless, this helps me understand you want me to focus on part C and specifically the graphing aspect. That's telling me you're struggling with the graphing aspect of this. And I can focus my help on that. Or you might say number 12, maybe it's that the problems we did in class didn't have fractions. So maybe number 12 has fractions in it in some way, and none of the practice problems had fractions in it, and they're just totally throwing you off, right? They're making the problem seem totally different to you. But sometimes that's not even it, right? Sometimes you're just like, I don't even know where to start with this type of problem, right? Or I'm not sure what this question is even asking me to do, right? If you're just struggling at the very beginning, right, that's a legitimate place to struggle. That's where people get stopped. People get caught at all different points in problems. And if the thing you're encountering is not even knowing how to start the problem, we should talk about that. And if you tell me that, so even though this may seem like it's like a cop out, a way to, include some words without being specific, but actually this is specific. This helps me focus on the beginning of the problem. And yeah, I'll probably go through the entire problem on stream, but I will focus particularly on strategies for getting started, and maybe even show a few different ways to do the problem, specifically to focus on different ways to get started and things like that. But if you hadn't told me that you were struggling to get started, if you had just said number 12, I may not have lingered too much on the getting started part, right? Because, I may have looked at the problem and seen like, oh, this has like a really big exponent. That's probably what's giving them trouble. And actually, no, you may have been like, no, actually, I can deal with exponents just fine. It's like, I just don't even know what the question wants. So this is where you can help direct me. Now, my hope is that you also just hop into the live chat and are asking clarifying questions and things like that, and helping direct me. And, if I sort of skip past a part of the problem that was a particular struggle for you, or you particularly wanted me to spend time on in chat, you could say, oh, hey, wait, hey, can you go back, or can you go more, talk more about that? Just little things like that. Anyway, this is the first place where you can really direct me into how I can best help you. And if the most specific you can be is just, I don't know how to do this type of problem, totally fine. But yeah, take that effort, 1 or maybe 2 sentences just to help direct me. And then the other really important part here is for you to attach helpful images. The key here is to be clear and complete. So clear just means I can actually read the text, all of the numbers, all the important bits, right? If the text is just a little bit blurry, especially on parts of it that actually aren't important for the problem, that's totally fine. It doesn't have to be perfect by any means. The goal of this form is not for it to be a barrier, but actually for it to be just a really organized way for everybody to submit questions, and for me to receive the questions. So take the best picture you can. This is why I said it might be best to do this form on your phone, because then you can just take the picture with your phone and just attach it right there. Boom, it's already there. But when you take these pictures, double check them, right? Go on your camera, take the picture, and then go to your camera roll and make sure you can read, zoom, make it bigger and make sure you can read the text. So that's the clear part. The complete part is, 1, make sure the entire problem is in the picture. Make sure you didn't accidentally crop part of the problem out when you took the picture. But also, oftentimes problems will have like a separate block of instructions, usually in bold or something, at the beginning of the set of problems. So in your textbook, block of instructions, and then problem, and then another block of instructions, or on a worksheet at the top or whatever. So make sure that block of instructions is either included in your image, or you take a separate image and also take a separate picture and also include that. Regardless, make sure I have the complete instructions for that problem as well. That way I know what you're actually being asked to do. And then, diagrams and charts and pictures, anything else that goes with the problem, right? Anything else that came along with it, including if it's just a blank graph or something, just a blank coordinate axis or something. If you include that in your image, I will use that when I'm going through the solution for you, so that you can see what it should look like on your paper, right? That's part of my goal here. So the more you include, so that I can work on the closest version to the actual problem that you're working on, right? And then the final thing to optionally include is any images of any work you've already done. That's just for me. I won't share that on stream, but it can help me see where you got stuck. Sometimes, students are like, I can't seem to get the right answer. Or like, I can't figure out what to do next. And it's because actually there was a step earlier on that left them in this place where they can't move on. But if we correct that earlier mistake, you don't end up there. Things like that. But it also just helps me see what your process is and see how you're going about doing the problem, so that I can answer the question not in the way that makes sense to me, but answer the question in a way that makes sense to you. And seeing your work helps me kind of quickly figure out ways that will hopefully make more sense to you. And again, you can be in chat asking clarifying questions and things. Again, including pictures of your work is optional. However, it is very, very helpful. Even if you don't think it's very much, it can still be helpful to include it, or pictures of your notes when you went through similar problems in class. Just anything that you feel is relevant. You can attach up to 5 pictures here. If you really feel like you need to include more than that to really give me a full idea of the problem you're working on, feel free to just email me, because you can include more images in an email. The other thing is if this is an online problem, so WebWork, Canvas, whatever, MyOpenMath, those sorts of things, you can screenshot it and include the screenshot. If it's a PDF, right? So like on Canvas or whatever, you've just been sent a PDF, like a packet of math problems, you can just send the whole PDF. And then, it becomes even more important that you're specific about your question. You help me find what question in that whole packet. But like, I collect math problems, right? And so if you send me a whole packet, if you send me more, so that I can see and I have access to more than just the problem you sent me. If it's slow, I might answer the question you have, and then I might also go through some other examples if I see some other interesting problems in there, and that may or may not help you out. Maybe you don't, need any additional help on anything else, but it could be useful to see an example of some of the other problems, or maybe you were struggling a little bit, but not enough to feel like you wanted to ask a question about it. Anyway, the more you include, the better my answer and more complete my answer can be. However, don't make this a burden for yourself, right? I know, I'm trying to be cognizant of how much overhead there is to just get a single math question answered, right? So the other thing here, though, too, is these don't have to be like a problem off of a worksheet or out of a textbook or off of what's it called, WebWork or something like that. This can be just a question that's come up from life. This could if you want me to just talk about a concept and work through some example problems of like the product rule or rules of exponents. If there's like a specific concept you're struggling with, you can submit that. And then again, it's helpful if you get in chat and ask clarifying questions. But yeah, you don't have to have a homework problem. You could just have a more broad. And then, when I say be specific, it's be specific about your slightly more general question, or be specific about the topic or the skill or the process you'd like me to talk about. And then in things like where did the question come from, you can just, say, from my life, that's fine. You can be more specific here if you want, but again, don't let this form be a barrier. Put whatever you can or are willing to put in each of these places, and then I will do my best to then parse it and give the best possible help and response I can. All right. Let's say you can't access that form. So everything I was just talking about is a big old waste for you. It wasn't a total waste because everything I talked about would be good for you to include in the email. And I put in here those guidelines. So if you're trying to make sure you include all the stuff I asked for, you can just go right here. So your name, and again, it doesn't have to be your real name, whatever you prefer, your pronouns if you care, the source, where does the problem come from, teacher in class, or just, how, where the problem came to you, such that you're asking it to me. Your specific question, right? Giving me one or two sentences about, telling me not only what problem you want me to focus on, but asking me kind of a specific question about that problem. And then finally, clear and complete images. And with an email, you include as many as you want. Well, there probably is some upper limit, but yeah, that's the process. That is how you participate, how you get your math questions answered. So here, let's go back to the home. Here. We'll check the form back in and check my email, see if we got any. Well, I know we have that question from my student. Okay. No responses yet. So let me go and look at this question. There it is. Okay, where are we at? So here. Excellent. Okay. So I need to practice this. How do I want to go about it? All right. So this is a question submitted by Ruby. Boop, boop. Boom. Boom. There we go. Okay. All right. And now, Ruby asks, I'm having problems with this equation. I really want to try and solve it by myself, but I'm stuck on this step after you take the natural log from both sides. I took the natural log from both sides and realized there is more than one exponent. Uh-huh. What should I do? Do I combine the exponents and drop it in front of the natural log? Okay, so a lot of those things do make sense. Ruby also sent a picture of their work. Oh, I see. Okay. So looking at this problem, use logarithmic differentiation to find the derivative of this function. And we have this messy function here. It's got a square root of x. It's got an exponential with a polynomial exponent, and then it's this big, 14th degree polynomial right here. This is intentionally convoluted. It does say use logarithmic differentiation. So what logarithmic differentiation is that it's a strategy, it's manipulation. We're going to use some algebraic properties of logarithms to manipulate this equation to make it easier to take the derivative of. Because if we could take the derivative of this using a combination of product rules and chain rules and things like that, right? It's just that it would get very messy. Notice we have 3 things being multiplied, so it would be a 3-piece product rule, which is fine. That's not really a big deal, but it does make it big and expansive and kind of a pain in the butt. And so what we're going to do is we're going to sort of decompose this using the algebraic properties of logarithms. And so what are those algebraic properties? Let's spell those out first, actually. Let's talk about the toolbox we're going to use here. And now, a good question to ask whenever I bring up tools and toolbox and stuff is, how do I even know that I can use those tools? And part of the answer is I'm going to lower my camera just a tad. I'm realizing it's sort of, okay, now that's too low. Oh my God, that's worse. Sure, that seems fine. How do I know when to use these tools, or how do I know that I can use these tools? And the fact of the matter is, you can use pretty much any tool anytime, so long as you know how to use it correctly. And if you know how to use it correctly, that will keep you from using it at inappropriate times. But that said, that doesn't mean sometimes you'll try something and it won't really work out. And that's part of this process, right? That's kind of like anything that you're learning and trying to do when there's a lot of skills and techniques. And I mean, even think about it when you're playing a video game or something, right? You'll try a strategy and it won't work, and you'll die or whatever, and get reset back to a checkpoint or whatever, and you'll just try again and you'll do a different strategy. Similar thing here. There's all these different strategies we have. So let's talk about what we're going to use here first. So these are our rules of logarithms. And honestly, talking about logarithms could be, actually, I may have already talked about that once. But we could have that could be a little mini section, is talking about logarithms and things. So really quick, if you have a log of any base, and inside that log, you have 2 things being multiplied, well, that will always be equal to the separate log of those two things being, and those logs being added together. So the product inside of a log is equal to the sum of separate logs. There's also, there's a corresponding one for division that would just be subtraction. I'm not going to write that one down because it's not going to be relevant for this one. We also have, if you have something with an exponent inside of a log, you can bring that exponent out front, outside of the exponent, down to the base level as a multiplier outside the log. We end up using this all the time, actually. This is super useful, right? This takes something that was in the exponent, which is a really inaccessible place algebraically, and it brings it down to the base level. This is the tool we use to make the exponent accessible, basically. Okay, I do believe those are our rules. Oh, there we go. Miro board, changing the organization of stuff on me again. Oh, you can follow along. So this is tracking me, but as I do more work, and some of the previous work I do might be off screen, really quick, I will just show you back on the website on the calculustutor.com. There's a button, go to notes. That will take you to this document. You're free to scroll around and look at whatever parts you want, and follow along with me. And if you're in there, what you can do is you can click my picture. There's this other thing in here. This is the computer that I'm streaming on. You can more or less ignore that. The one with my face is the one you want to pay attention to. If you click on my face, then if you have it loaded in your own tab, it will still follow along with me. Or if you want to find where I'm at, you can jump to it and then you can tap it again and it'll stop following me. But yeah, so there's a little tool how to use that. Let me get rid of that. Okay. Okay, so these are the rules we're going to use. Now, here's what we're going to do. We're going to so first thing I'm going to do is I'm going to rewrite this function a little bit. Pretty much always, I will rewrite a root notation into an exponent when I'm going to manipulate it. Okay, so this is, so remember, a square root is the same as a 1/2 exponent. This is e to the x, which is itself squared. And finally, we have this polynomial. Okay, so now what we're going to do is we are going to take the natural log, which is a special log base e. And this log just has sort of the nicest properties of all of the logs. And so this is the one we use. And so anything I do to one side, I have to do the other algebraically. So this is totally allowed. There's a few cases where this isn't allowed. We couldn't do this if y was ever going to be a negative number or 0. So there are a few caveats here. But looking at this function, y could never be 0 or negative. So could it never be negative? I don't think it could ever be negative. Yeah, because we have that square root. So, but it's a practice problem. We're pretty sure it's going to work out. So on this side, we'll have natural log of y, and that might seem a little weird, but we'll leave it alone for right now. And over here, we have the natural log of all of this stuff. So this ln, that's just a special log, and actually maybe I'll include that here. Log base e. So e is Euler's number. We just call that natural log, and it gets this special notation. And so I'll make a note here that e is approximately 2.7128 ... Now I'm second guessing. Oh, I know how to check it. We'll just go into my calculator and do E. 2.718 to 2.71082, not 28. Oops. Sorry about that, y'all. And also it rounds. It's 828. 71828. ... It goes on just like pi. This is Euler's number. Just a special number like pi. Cool. So this is just a special log that has some really nice properties. So all of these other rules that are right here, these still apply. So we have natural log of 3 things being multiplied. And so we'll split that into the natural log, into 3 natural logs being added. Boom. Okay, being careful with my parentheses here, especially with this one that has a exponent on the outside. Okay, and now we can mess with these exponents, right? We can use this rule right here, take this 1/2 and bring it out front. This is 1/2 natural log of x, okay? Plus, we can do the same thing here. I'm trying to keep straight in my head. Yeah. This is the same. And I think this is what my student had asked about when they asked, I realized there is more than one exponent, so I'm not sure if it's this exponent, this exponent, this exponent, or if it's this e to the x squared. I'm not sure exactly what aspect of more than one exponent they meant. So here, this x, remember, this is the thing that's in the base, the e. Then this x, while it does have an exponent, it is itself in the exponent. So that's what's going to come out front, is the entire x squared leaves behind a natural log of e. It's going to give us another rule we're going to need to do. I'll write that in a second. And then finally over here, we'll bring the 7. And there we go. We've now split that up. There is a little bit more simplification we will do. So another rule we have is that if the base number matches the number inside, so log base b of b, logarithms are just telling us about exponents. A logarithm is answering the question, what exponent do you raise the base number to turn it into the number inside, the argument number? So b to what exponent is b? Well, b to the first is b. So a log base b of itself is just 1. So that's our identity. So I wanted to point that out for right here. I guess instead of scrolling back and forth, I can just zoom out a little bit. So right here, remember, natural log is log base e of e. So this right here is just going to equal 1. Okay. So now we will have 1/2 times the natural log of x plus x squared plus 7 times the natural log of x squared plus 1. Excellent. Okay. And this is what the natural log of y is equal to. Why do we care what the natural log of y is equal to? Well, one of the properties that the all logs have nice derivatives, but particularly natural log has a really nice derivative. So let's do another little note section here. We'll do it as a separate box. So this is derivatives of logs. You know what? I know it's going to take longer, and I do apologize, but I would like to make my notes legible. So give me 1 second here. There we go. All right. So if you're trying to take the derivative of a log of some function, right? So I'm going to show our chain rule process here, because very often it's not going to be just the log of x. And we can see in our problem, we do have a natural log of x. That one's kind of nice. But then over here, we have the natural log of x squared plus 1. There's more stuff going on, right? So let's talk about what happens when you take the log of a function of x. So the derivative of a log is just 1 over whatever was inside that log, like that. Then you multiply by 1 over, or you're dividing by technically the base number. Now that's just the derivative of the log base b of something. Then chain rule says now that we've taken the derivative of the log part, we go inside and take the derivative of f, which is, what was that? Which is f prime of x. And now we can simplify this as f prime of x over b times f of x. I'm going to double check that really quick. I second guess myself, and then I feel like I can't move on until like once I've questioned myself. Pop in. Aha, there we go. Oh, there we go. Oh, oops. It's supposed to be the natural log of b. Oh, oops. Okay. Sorry. This is times 1 over the natural log of that base number. So this is 1 over the natural log of b times f of x. There we go. There we go. Okay. Now, this natural log, though, if b was equal to e, then the natural log of e is just 1, like we said before. So that gives us a special derivative, or a special case. If it's the natural log of some f of x, the derivative is still going to be, it's still going to look like this, except our base here is e, so it'll be natural log of e, which will be 1. So we'll just end up with f prime of x over f of x. And this right here is why we took a natural log rather than any other log. A natural log means we don't have this floating value of this value of b floating around. I'm trying to get this to be the same width, and I'm probably spending way more time on that than I need to. Whatever. Okay, it doesn't matter. So that is our there we go. Oh my gosh. There we go. Okay. So now that we know our derivative, because remember, our whole goal is to find y prime. Oops. Sorry about that. I want this scroll. There we go. Our whole goal is to find y prime. But right now, we just have the natural log of y, right? However, we can get y prime by taking the derivative. So what we're going to do now, and taking the derivative is similar to doing anything else. If we do it to one side, we have to do it to the other. So I'm going to take, oops, let's make this legible. I'm going to take the derivative of this side, and I'm going to take the derivative of this side. So notice this is d dx of this and d over dx of this side. Whatever I'm taking the derivative with respect to on this side, I have to do on this side. All right, so we want to talk. So we're taking the derivative of a natural log here. So here, the derivative of a natural log is just the derivative, which is y, oops, which is y prime over y. I'm going to move this down here to just be more in line with the derivative stuff. So y prime over y equals, and over here, because these are all being added or subtracted, we can just go term by term. I meant to mark in this where I started talking, and I didn't. Here, I'll still mark it. That way, at least I can scrub back. Okay. So here we can go through one term at a time. So 1/2 the natural log of x. Well, it's a 1/2 multiplier. So we're just going to get a 1/2 multiplier times, and now derivative of natural log of x. Well, x prime is just 1 dx over dx. So we're just going to get 1 over x. That's nice. Okay. And that's the whole derivative there. Now we move on to this one, derivative of x squared. We use power rule here, bring the 2 down. X, 2 minus 1 is 1. So this is just an exponent of 1. Over here, we have a 7 and a natural log. So the 7 multiplier will just come along. And again, we have a natural log. So the derivative of a natural log is always a fraction. The derivative of the inside goes on the top. So the derivative of x squared is 2x. And then the original function, x squared plus 1, goes on the bottom. And now we can simplify this a little bit. We'll make this 1 over 2x plus 2x, which is 2x over 1, plus this 7 is a 7 over 1. So we can just multiply it in, and so we can get 14x over x squared plus 1. That's not too bad. However, this is what y prime over y is equal to. We just want y prime. Well, we can just multiply by y on both sides, but we don't want a y over here, right? We don't want to mix our x's and our y's. We just want x's. Here's what's nice, though. We know what y is equal to because that's what we started with, right? At the very beginning, they told us that y is equal to, I'm going to write it as x to the 1/2. Actually, I wrote it up there already. Times e to the x squared times x squared plus 1 to the 7th power. And because we know that, is this still following me? Okay, good. Sometimes the thing that follows me breaks. Okay. Oh my gosh. Erase that. Make that a clear 7. 7. Okay. So now that we know what y is, what we can do is on this side, we can multiply by y. And that'll cancel out. And on this side, we can multiply instead by x to the 1/2 times e to the x squared times x squared plus 1 to the 7th. Right? We're going to multiply by all of this. And so what we're left with, the y cancels out, and we're left with y prime is equal to all of this stuff times that original y. And so the order you write this in doesn't terribly matter. And because there's no addition or subtraction between these elements, there's addition or subtraction in here, but it's already inside parentheses. Because there's no addition or subtraction, we don't actually need these parentheses. So we could write this. I would probably write this as x to the 1/2 times e to the x squared times x squared plus 1 to the 7th times, and now it's times all of this, which is 1 over 2x plus 2x plus 14x over x squared plus 1. Boom. And that is our solution. And so I'll go back. What I like to do is go back up here and write the solution in the box here, just so at a glance it's really easy to see. Squared plus 1 to the 7th times, and then it's times 1 over 2x plus 2x. There we go. Boom. Copy link. There we go. So I should be able to. Oh, you can't see that on your screen, right? Because it's just on my tablet. Ha ha ha. Okay, that's the whole solution. I will email this to my. I'll respond back to my students' email, and yeah, let them know. About where are we about? We're about 54 minutes in. Um, okay. So I was trying to find where in the stream it was. I don't think that's actually going to be helpful right now. So what I will do, copy link. Okay. Oh, you know what I think I'll do? I will open our so where you saw me doing this work on the Miro board, right? I guess what this where the screen I'm sharing right now, this service Miro. I each student I work with that I work with one on one, we have our own Miro file that we can collaborate in. And so I think what I'm going to do is just paste this into Ruby's Miro file. There we go. That's nice. That'll make it easier for Ruby to find it. Instead of linking to a different Miro board. And there we go. We have a math question, and that is the type of thing I'm talking about. I try to be really thorough, which means, yeah, it does take me sort of a minute to go through problems. As I get more and more problems and I have to make better use of time, I'll get a little bit more concise. But my goal isn't to just get the problem done for you, it's to teach, right? And teaching takes longer than just doing. So our goal is not to just do the problem. So now we did that. We'll go down here. There we go. And now I have a clear space where I can say, hey, submit your math questions. I don't know. I don't necessarily need that, but I has it and I can do it. So I may as well. Just as a heads up, there won't be streams Wednesday or Thursday this week. I just have conflicting appointments. I will say though, if there are question submissions, so please still submit questions. If I see there are questions waiting to be answered, I will do a special session. Now that means that if you submit your question, you don't necessarily know when I'm going to do that outside of the schedule, but that's okay. You can watch the VOD. So please still submit your questions. Just because there isn't a stream scheduled doesn't necessarily mean a stream won't happen. It almost definitely means a stream won't happen at the scheduled time. But please still submit your questions, and I will still find a moment to record myself answering them and make that available. Excellent. Well, it was nice to have a question to focus on. So now, let's check and see if any other questions came in while I was doing that, huh? Either via email or the form right here. Am I back? Can you hear me? Seems like it. Okay. I guess I can test. Yeah. Seems like you can hear me. Do you hear the echo? I was just checking the stream itself. I had a thing yesterday. So much. I was muted for so much of my stream because it didn't. I wasn't muted according to the UI, but when I went back and rewatched my stream, there was no. It was because I think it's because I had muted and unmuted myself a few different times throughout the stream, and I think at one of those points, especially early on, well, I had done it a bunch, even afterwards, and it didn't unmute, which is weird. So there's just some error right from the beginning. But there is an indicator about whether it's getting audio, and so I just need to remember to double check that, especially when I come back or have muted it and then and all I had to do was refresh the tab that the stream is in, and that fixed it. But I didn't do that for like 30 minutes. So anyway, no questions just yet. We're getting on towards the end here. Okay, there we go. And then I have, like I had mentioned, I have a student I'm kind of nervous about. It's so strange to be so anxious about. But yeah, I'm so aware of how little agency young kids have. And like I don't really understand how to justify spending time on math to a student that young. I think them having math homework and homework that they're supposed to like sit and do a bunch of problems is a bad expectation for middle schoolers and young kids. Like, give them something interesting to do that will teach them the material. Don't just give them a bunch of practice problems. And so I am curious to see what sort of work this kid has. This will be our first session. And then there's the whole thing of just, it being with a neighbor, and so the relationship is sort of fraught, or not fraught, but just, I don't want to, if it goes bad, you know, I've had a few students and families here and there, just only like a couple throughout my career, but where it just doesn't work. It's just not working. Um, and it sucks that when that happens, and it sucks to have to sort of make that call. But at least when it all shakes out, I just basically never have to see those people again. Being neighbors, you know, I'm going to see these people around the neighborhood. I may have to interact with these people. So, it would be nice if it went well. And so my plan is just to go and ask this kid about his math class. What's your math class like? What's your teacher like? How's the class going? What do you want to be different about math? Yeah. What's your class like? What's your teacher like? What do you want to be different? Ew. Sorry, that's probably kind of gross. My nose is running for some reason. Which I know it is. Because I'm really. My nose is running. Oh, man. I'm sleepy, y'all. Ugh. Whew. Okay. I think I'm headed towards. Oh, oops. No. Cancel. There we go. Silly, silly, silly. Oh, I am tired for sure. I think I like this setup better. The light's better, right? Instead of being backlit, the the light coming in through those windows is giving me front light. Um, and it's not like blinding the camera and just everything. But I actually have more room here. Yeah, it's pretty great. I'm liking it. Sorry, got a little catch in my throat. Okay, here, I'm gonna go blow my nose. I'll be right. All right. Howdy, howdy. I'm going to do one last check for questions, last minute questions, and then I think I'm going to sign off. I need to get the website updated too for tomorrow's stream. So tomorrow I'll be back at 9 p.m. for the night stream. Okay. See you Tuesday night stream. Shareable link. There we go. Let's go to the website. Man, I'm sleepy, y'all. Tired. Well, there we go. Everything is updated. And we're ready to go for tomorrow. I will be, that's where my new monitor, or that's where I've moved the monitor that has my view of the stream. So you're going to see me looking over here a lot for a little while. I'll get used to it. That's all for today. Back. Excuse me. I'll be back tomorrow for the Tuesday night stream starting at 9. I'll be live from 9 to 10:30-ish, when it's really, really slow. It's, hard to stay motivated to stay on the whole time, but I'll try to stay there for most of it, just like today. Yeah. And then reminder, no Wednesday, Thursday stream at the scheduled times, but if I get questions, I will make a stream to address those questions and make those responses available to the people who submit the questions. So thank you so much. I hope you have a good rest of your afternoon. I'll see you tomorrow night. Bye.